Hello and welcome back. My name is Angelina Quan, and we're gonna continue our discussion from last time about number theory. So, like I said, number theory, there are primes, they're composite numbers, and these really help out when we solve problems. So, today I'll be talking more about prime factorization. So prime factorization is basically breaking down composite or prime numbers or just integers in general into a factorization. So what factorization is that you get a number and then you have prime one. Let's just say prime one is a number. It could be two, it could be three, it could be five, it could be seven. And then there's an exponent. So I hope you know what exponents are. And then prime 2, exponent 2, and then prime 3, exponent 3. And you probably already know this equation, so I'm not going to explain too much on how it works, but basically you break a number into primes to some power. And then the magic about this is that you could find so many different properties of the number x through this prime factorization. For example, you could find the number of divisors it has. And how you do that is through e1 plus 1, the exponent of prime number 1. So let's say the number is, I'm going to pick an easy number for myself, 220, or let's say 420. That's 440. That's a good number. So that's 2 to the second times 5 times 11. So you can see P1 here is 2, E1 here is 2, P2 here is 5, E2 here is 1. So if I don't write an exponent, just assume that it's a 1. And how you find the number of divisors it has is that you add up all of the exponents by 1. And I'll explain how that works in a second. And that gives you the number of divisors. Really cool, right? Because how it works is that if you have a divisor of 440, let me clear the page. If you have a divisor of 440, then it must be expressed by these three numbers and with some exponent, right? The exponent cannot be larger than 2, because if it's larger, then that's 880, and of course 440 can't divide 880. So if the exponent has to be larger than the exponent of the, let's call it the mother integer, then you know that the exponent has to be less than that. And that since you want the exponent to be positive, because you know what happens when an exponent is negative 2, let's say that, then you get 1/4. And the thing about 1/4 is that the other primes, since they're primes, they can't divide 2. So if we have 1/4, then we're gonna get a fraction, right? Because we can't have something else that cancel it out. So if we have 1/4, that's basically impossible to get an integer. And what we're talking about is positive integer divisors. So we know that it has to be an integer. So the exponent has to be an integer and less than or equals to 2. So now you have choices. You only got so many choices because it can't be negative. So it starts with 0, 1, 2, and if the exponent is, let's say, e1. But over here, our e1 is just 2. So which equals 2. So, the exponent of 2, the prime 2, and the divisor's factorization must be 2 to the 0, 1, or 2. Now this becomes a counting problem, and it may not seem obvious to you at first, but what's really, really cool about this is that 440, So you know the divisor is 0, 1, or 2 times 5 to the 0 or 1 times 11 to the 0 or 1 power. Now, this is an arrangement problem because now you're just picking, let's say, 0 and 0. 0, 0, 0, 0, that gives 1. 0, 1, 1, that gives 55. 2, 0, 0, that gives 4. So what you're trying to do now is to count how many different combinations you could get with 0, 1, 2, 0, 1, and 0, 1 over here. And that is what the multiplication is for. So over here, you got 3 choices. Over here, you got 2 choices. Over here, you got 2 more choices. So if you want to find the number of combinations of all of these choices, you multiply them. 3 times 2 times 2 gives you 12. And that is number of divisors for 440 because that is the number of arrangements for the divisors exponents that can happen. And that covers all the cases because, as you know, it cannot be a fraction, cannot be over than the exponent of the primes in 440 in the prime factorization of 440, and it can't be a negative number. So 1, 2, 3, 4. Now we know that we have 3 times 2 times 2 equals 12 number of divisors. And you can generalize this, which is so cool because now you can solve limited a number of problems with this. So if you get any integer, you know that if its prime factorization is P1, E1, P2, E2, like that, you get this. And you're done. This can solve you any problem you want. I hope you're recovering from this coolness, and thank you so much for watching, and I'll see you in the next video. We'll do much more cooler things.